Hello guys, how you doing? Um, yeah, it's another day. I think I've set up my streaming system as much as possible. Okay, this is where the camera is. So yeah, today I'm going to be discussing about setting up access control on a backend, proper access control on a backend. And this is an interesting topic because when you have the prototype of your product, you might want to leave from a basic is the user or is the owner check. By checking user IDs, you want to go to something more robust, especially if you are building multi-tenant platforms or platform where you have workspace, projects, folders, and things like that. You might want to build something more robust where you can assign roles and permissions. There are different ways to do that. We have things like RBAC and whatnot, all manner of terminologies, and depending on your requirement for your project, you can go about it in different ways. Like you see, like on the base level, like applications whereby a user sign up, a user manages their billing, they don't need to invite anybody. At the very least, people do password sharing. Like you could just do user ID checks for resources and then provide that resource to a user. But when you have an extra layer on top whereby a user can sign in, create a workspace and invite people, um, on a basic level, you can create roles, right? Or aside roles, like on a basic level, you can just permit anybody who is um, a member of that workspace to access a resource. On another level, you might create roles and then tie those tie those roles to endpoints, right? And people who have those roles attached to their membership can access resources. But even at a higher level, especially when you have platforms like CMS, you might want to make it more granular, like um, give access to particular, maybe in CRUD now, you want to give creating access, reading access differently, or access for different actions. And even in some instances, you might want to determine access to different fields in a particular resource. By resource, I mean like a database table or a collection on a NoSQL database. No, I guess resource is an item, right? It could be a list of documents. Resource is an item inside of that table, really. You can call the table a collection as well or a database, you know. So I'm just going to be going into FigJam. We'll quickly model one way, I believe is a robust and interesting way to go about it, especially when you have like at the edge of permissions requirements, right? Like not like the edge because they are much more granular access systems that can be a bit complex. But even then, I still seeing like big applications like trying to group things. For example, on Cloudflare, there's some kind of grouping going on, grouping on zones levels, grouping on different features or pages, of the app. So we're going to be going through some just maybe in other videos we can go through like some more granular, or let's say some deeper access requirements, like even blocking fields and things like that. So let's just get started illustrating it. So if you look at FeedJam here, I've actually gone ahead because I don't want this video to take too long. I'm going ahead to draft like some thoughts together. This is most of my rough work, but I'm just going to get started on the side here again. So our first scenario here is that we have a user, right, who is signed in. We know that the user via their session, maybe their cookie session or JWT, whatever. We know that there's a user available, right? And the use case here is that the user is trying to access a file that belongs to a workspace, right? So in this case, we have a file belonging to a workspace, right? And then this particular file now, we can access it in different ways, right? So we can access it by one, being an active, not just a member, but an active member of the workspace, meaning that someone who has been blocked or someone whose invite is not complete, you don't have access to that file, right? Then number two, we also want to see if that file is public, right? So a public file should allow for access, right? Or will I call it the visibility status? Let's say file visibility. Let's say file visibility, right? In some cases, it could be the share settings, whatever settings have been set up for the file. If the file has been set up to only be shared by link or by organization or to be made public, right? So let's just call it file visibility. Then another one could also be even in the workspace, you could have a situation whereby project member, so it could, even in the workspace, maybe a file is only accessible to certain project members. And then finally, um, anyone who has an API token, right, can access this file, right? So via perhaps an endpoint. Now, this is our scenario, right? The next thing when a user wants to access any resource on our backend, usually there are two major interfaces, but now I think they can even look 3 or 4 of them. You know, commonly we have the UI interface, right? Then we have the API, just calling API endpoints. Normally the UI calls the endpoint, but the developer can call an endpoint. Now we even have AI tools calling endpoints, MCP servers, and all that. You know, so but this is the scenario we are working with, and these are the different ways one could get access to a file. So now, whichever way they're coming from, they need to hit an endpoint for our server, right? So drafting that endpoint now. So let's call this endpoint. I'm not sure why this is center aligned. So drafting this endpoint, depending on the way this resource is, usually would determine the URL slug, right? So if you are building an application that is only accessible via UI, you could have a slug system whereby you have workspace slash workspace ID slash file slash file ID, right? And then anyone that is trying to fetch this file could limit the query down further by workspace. But that doesn't always matter. You know, sometimes you can make it linear because in applications you are interested in a particular resource, except when you are doing like multiple queries. But usually are interested in multiple resource, a single object or a list of objects. So you could just model the endpoint like this: files, then file ID, or files if you want to access a bunch of files, right? And accessing a bunch of files is another kind of permission similar to this, but like maybe with some tweaks. So now want to access a particular file, right? We could the next step I usually think of in modeling this kind of access systems is to look at what are the contexts that will be needed to fulfill the scenarios above, right? So if you look at what we have here, if the file is belonging to a workspace, right, we need let's just call this context. We need the workspace, right? Or maybe not the workspace, we will need maybe the membership and workspace, right? So we need the membership to know if they're a member of that workspace the file belongs to, right? But most of the time, we would even need the file itself in the first place, right? Depending on how you're structuring your query, right, you could, okay, no, let's not go that far. We're just looking for a file. We don't know much. We just know that there's a user. This user wants a file, right? So actually, depending on how they are accessing the file or trying to access the file. So what I mean by that is I can call it request context. So what I mean by this is there are certain hinters that could be in a request that would let you know what is the first set of context that you need, right? So you can call it request context and then call this required context, right? So request context could be that the user ID is one of it, user ID, right? So if the scenario above was that we don't have a workspace, we just know that files only belongs to users, we could just use the user ID from the user session and then fetch the file for the user, right? So this one context that we can have. In some cases, we can have the workspace ID in the slug or headers, right? We could have stored the active workspace in the slug before the file or in the header as well. This same thing goes with also the project ID, right? Just in case the file is further scoped into needing a project membership, right? Then if we are talking about like let's say we need a particular kind of file, so the context would need, or no, the request context to be looking for would be something like let's say a query or a search param, or what do you call it? So let's say a query, right? Where it could be something like visibility equals to public, right? So this request context gives us an idea. Okay, furthermore, right, if we looking at API tokens, we could have a header, right, or a query carrying the token, right? So the token the person has. Now, all this, depending on the way you want to craft it anyway, but I would suggest like loading the context first, and you can load all of the context immediately together so that your request is much faster. So one thing I see folks do sometimes is that they write a backend whereby I'm fetching the user, fetching the membership, fetching the workspace, fetching the resource, fetching the token. You have 5 requests. If each of them are taking 300 microseconds, you're having almost an hour, a request that takes almost an hour, not to talk of optimizing the database queries or the indexes. So you could actually load all the context together, right, in one place, and then use it in the next step. So loading of context can be dependent on what that's loading of the required context. I should name this properly. So loading of the required context should depend on the request context, right? So if we have a user ID, obviously we should be fetching information about the user so that we would know if that user is actually an active user on the system, if that user ID actually is registered in the system or not just from nowhere, right? So obviously when we have a user requesting, there are cases when a user is not requesting something. For example, when you have an API token, right? In that case, there's no point loading the user context. Like there's no point for that, right? But you could have the user and require to load the workspace, right? There are even instances where you need to load workspace context without needing the user. Let's say there's some public directory whereby workspaces can post stuff. You want to check if a workspace is active before showcasing their public item. All that is possible, right? In the next phase, right, let's say from the user ID, one of the required context is the user document, right? The workspace, project, and project membership, right? The resource itself, that's the file itself, so that we'll know if it's a visible file, what are the sharing settings and all that. Then we could also require the token, right? So the next phase, usually, how do I make this thing center up? Is still on, like this is, we are on the route now, right? We've not even gotten to the handler yet. What will handle the request? And usually, when you have a simple CRUD system, what all the handler does is like to call maybe the model or the database service and fetch the data. But there's certain things you need to do before you even get to that point. We are not always fetching data in backend system. Sometimes you want to perform an action, you want to process a PDF, generate an image, or use an AI chat system. So after we've gotten the required context based on the request context, The next phase is just implement simple guards, right? Like I think route guards, like route guards in front end, and they can do basic things like in your route guards, just do things that don't require API calls. For example, is let's say you implement an is user guard, like make sure this person coming forward is a user. Probably this, we should be doing the guard even before we get here, right? Before we get to the required context, actually, so that we don't waste making request calls. We need to know if this is like, okay, so when I define backend routes, I usually like to first define like an array of objects or an object of objects where I specify information about that endpoint and then use another function to register all of it. So just look at this as the simple definition. Maybe in a later video, we'll actually go into code. But first, we have to think about the concept so that we can make something solid and testable. Right, so these are the guard. Another kind of guard I like to have is rate limiting, stuff like rate limiting, right? Rate limiting, yeah, basically mostly these two, right? Rate limiting, I can implement rate limiting with Redis or Memcache with some cross-server syncing to make it as possible. But essentially, your guards shouldn't be making any expensive API calls, anything that would take more than 500 microseconds to do, right? So when you're settled with your guard, you've rate limited, you're sure that this is actually a user, right? Then you can get into fetching the required context, right? And the context, you should, as much as possible, fetch everything that is required at once using a promise.all. So you already know what the request context is. This guy is coming with a token, right? So if someone is coming with a API token, I don't need to fetch the user. There's no point finding out who the user is, right? Except for some reason, like maybe blocked users, their token shouldn't work, but I probably should delete the token or disable the token in the first place. So we use promise.all to fetch all the context at once, right? And if probably if any of them fail, you should just end the request, right? But you should fetch all the required ones at once. So in instances where we have API token, we don't need to fetch other things. We just need to make sure that the token is valid. Probably we might need to fetch, we might need to fetch the user of the membership still if we want to be sure that it's still valid. But like I said, when let's say you disable a user, you disable a workspace, you should create a function to also disable several other access routes like the token and all that, so that I guess you could implement all form of service. Using promise.all is still fine. You can still make the request. And mind you, based on the endpoint and the action you want to do, you can implement several safeguards. It's fine. For example, making get and list requests should be faster naturally. But when you're creating a resource, you should take all the time you need, make all the calls you need. When you are making a delete action, you should take all the, like if you need to even do an OTP, whatever, you don't do deletes all the time. So especially when you are doing bulk deletes, you can have a lot more checks, and all that. But usually for get list requests, you can try to optimize as much as possible while still being safe. So now after we've selectively fetched this required context, we can implement several other middlewares. Like for me, one of the middlewares I like to register is like, or maybe using a hook, is to set up logs, but we'll discuss logs in other videos. Like I set up a log, like register a log, or like get it started when the request is starting, so that I can also capture how fast, like the request time, what action is being performed, the endpoint, and afterwards, after the entire request is complete, I also want to store the status of that request. Did it go through 0, 200, 300, 400? Then in a safe way, like not blocking the request, I want to send out the logs So we'll discuss logs some other time, like different kind of logs, what they are useful for. Whatever that middlewares you want to run, you know, then the next step is to run your policies. Right? So policies really involve what a user needs to meet before they can be allowed to the handler. So the last stage is the handler. The handler is where they can actually get the action done, or they can get the resource, right? So sometimes I also add fail safes, something I call fail safes before the handler. Still another kind of middleware, right? So you want to implement conventions that block you from making silly mistakes or the system from being gained and things like that. So if somebody were to try to do something funny because of the convention you set in the place, it could be caught and blocked. Trying to think of some of the fail safes that I actually do. Sometimes I want to check okay, yeah. Before that, we could, one middleware that is very important is actually validation, using things like Zod. You want to validate the request body. You might even validate the query params, the search params, all that. Validation is very important so that ensure somebody is sending the right amount of payload, not sending weird fields and all that. So validation is very important. And then there's also something I call a post handler, like so post handler, or like I call it post request, right? Or I call it response wares. Things you do before actually responding at the end of the day, right? So there I can do things like passing the response body to make sure like I'm only sending proper fields. I'm never sending passwords. All those things, they could all be kind of fail safes as well. Making sure you're not sending any extra information as well. So the fail safes, I'm still thinking of the fail safes I normally implement. It usually has to do with like conventions to block developer errors and when users are doing silly things, but maybe I'll remember something. So for the policies is where you really implement what you have from above. So like around the required context and the request context, you would now have different policies, and you can implement them using different approach. For example, you can have a policy system where you allow if any item passes, or allow if all passes, and sometimes you can combine them also depending. So there are even instances whereby let's say is admin, usually I recommend creating like separate endpoints or systems even for admins, but depending on your app. But you could have a system whereby your admin is still a normal app user and all those things are intertwined, you know. So for your policies, you could implement by allowing if any of them pass, or if all of them passes, or the combination. So for example, now we can have a policy whereby the file, access to the file should be allowed if is active workspace member, right? And then you want to allow like probably like a race promise or something, whereby the first once they achieve access, you can allow them proceed, right? Once they achieve access. So for example, you can run things like is what's it called? Is valid token, right? And then you can even make it dynamic such that, or not dynamic, you could keep the arrangement. But for example, if I come to the is valid token and there is no token in the headers, I immediately skip. So I don't make any request at all. I immediately skip. There's no need thinking of that policy, right? Then I go down to, is this person an active workspace member? And sometimes you don't need to make a policy that is a repetition. I do see that sometimes, whereby somebody writes is user and then still write is active workspace member, the person being a user would not grant them access to that file. So there's no point having such policy. Inside the is active workspace member, you can also still do a check that this person is a user, and then do a check that this person is a member. You can also further do a check that this workspace is active. Another thing we could also do is resource public, right? So this depending on how this request or like this endpoint is used, you can stack the policies. Like if it's an endpoint that is mostly for API calls, you should stack that first, endpoint that mostly for public requests. And sometimes it's just best to create a different endpoint entirely, right? So that it's more linear. You don't have all of these policies in one place. Sometimes you can create a separate endpoint, right? Now, what I mean by making this robust, sometimes you see people writing all this logic inside of the handler, but then your app might start with 2 endpoints, 3 endpoints, 5 endpoints, getting to 500 endpoints. You want to create a system that is scalable, robust, and testable, something that your test can confirm that your logic is okay, right? With other checks that you have, other fail-safes, and other mechanisms you have. You want to make your system robust so that you scale. You can easily scale, and later on we'll look at writing better handlers, creating backend, model services, controllers, actions, all those things, right? Then even furthermore, I think something I forgot to mention is even down to has required context could also be workspace permissions, right? We could have this instance, right? Workspace permissions. So we might not necessarily have it in the request context that we need to use permissions. We could still pass that with the query param that we need. No, we don't need to pass that actually. We could just have a policy that says as workspace permission. Right. So depending on where you're storing the permission, you could be storing the permission in the user's membership as well. Of course, you should have made sure that you validated the payload coming, that they're not able to modify permissions themselves. You can do that in the validation and do that in the service code, to make sure that nobody is able to, like, a user is able to modify, assign themselves permissions, right? So this could also be another policy that we have. For the token, then we could also have a check for is admin. So if it's app admin or something like that. So once you realize that this person is an app admin, you can let them through. But that probably be at the end because we want to prioritize users, right? And things like that. So there are also instances whereby you want to implement and, right? When you want all conditions to pass before letting the user through, you can use your imagination for that. Maybe you want to combine that, okay, this person must be a valid workspace member and they must also belong to a project. But it might just be better to just combine it here and say, instead of having this one, you can create an extra one that say is workspace and project member. You could do something like this and save yourself any extra checks, right? And then here we go. Yep, this is a robust backend access system. And to make it even interesting, you could also even pass the reason for why the request was honored. You could pass it down to the logs as well, like, hey, this person was able to access this result because his valid token went through, right? And you can validate that from maybe the query param being in the logs if it doesn't have sensitive data, of course. Yeah, I think sometime in the future I'm going to build or show you guys like a UI backend, A backend route visualization system. Because I'm a designer, I do things like that, whereby like I see things from the visual aspect, right? So you'll actually see a simulated backend whereby you could slow down the request by adding set timeouts, wrap all of these different steps inside like a wrapper function. And then we see when the request comes in, when we get the context, we know all the context coming in, we run the guards, we run the what's it called? We get the required context, we run the middlewares, then we get to the policies and all that. So stay tuned. If you like stuff like this, I'm basically making these videos because I think I have a different perspective to share, and I also want to see if other people can relate and also learn from other people as well, so that I can be a better engineer. And yeah, we're in fun times with AI and everything. We can basically do more, can build more robust systems. Thank you for coming. Have a nice day. Bye.